everyone, today I'm gonna do an example question on calculating all four species when you have the situation C. Okay, so situation C is that you have 0.05 mole of Na2SO3. First of all, you have to notice, okay, so what you're dealing with. Okay, so Na2 sodium sulfite. Okay, so when you put this into solution, this is what you have, right? Okay, so you're gonna have this two. Okay, as we said, this will be pH neutral, so our major species will be SO3 2 minus. Okay, so that's our major. Okay, and then this is our most basic form. Okay, so our major species in this case will be the most basic form, and then we know what we're gonna do. Yes, we're gonna treat it as monobasic solution. Okay, so this is basically you learn how to solve when you have a monobasic solution. So we're gonna have this solution. What's the base? Yes, base will be Kb. Okay, so this is our Kb1. It's gonna give us our the intermediate and the OH. Yes, because it's a basic solution. Okay, so it's going to produce OH in our solution. And of course, we still have our shortcut. We're going to do this. And then remember, now we're expressing Kb. Okay, so Kb will be x squared over 0.05 minus x. Okay, and Kb, you know, how do I calculate Kb? You know Ka value, then you can calculate Kb. And then, however, in this case, since it's diprotic, actually diprotic, so that Kb1 will equal to Kw divided by Ka2. Okay, so this is very important for you to notice. So that's how you calculate Kb. Okay, so we're gonna do the calculation, which will be 1 times 10 to the negative 14 divided by 6.73 times 10 to the negative 8. Okay, so then you get your Kb value, and then in this case, let's actually calculate. So I'll be x squared over 0.05 minus x equals to 1.49 times 10 to the negative 7. You always can check small approximation if it's valid by using this. If k is smaller than 10 to the negative 4 times f, if so, the small approximation is valid. In this case, when you see it's 10 to the negative 7, that's quite small, so you probably could you already probably sense that you could use it. So small approximation will be valid, so you can use it. That's a good news, right? You can use small approximation, and then you can calculate the x will be 8.62 times 10 to the negative 5, and this equals to what? Let's go back. X is what? OH concentration. Okay, so OH concentration, and then you go, also this X equals to what? This also equals to HSO3 minus. That's something good we want. That's one of the things we wanted to know. So we already have this. Okay, so that's good. So that's the concentration of that. You go, what about pH? We can deal with that because we know OH, then we can calculate POH. Negative log of this 8.62 times 10 to the negative 5 give me POH will be 4.06, then pH equals to 14 minus POH give me 9.94. Again, this value pH, we're dealing with the base. 9.94 sounds about right, so that's good. Okay, so then we got our pH, and then we have the other two. Again, we have the reaction happening, so it's gonna go to the other direction. But before that, we actually know that the concentration of that sulfide ion, right? The concentration of sulfide ion, we already know. Okay, what this will be, right? We can know it from this expression. Okay, so then it's that sulfide ion will have that original, the former concentration minus that 6.92, whatever the rest. Okay, so then you get about, right? So this is such a small value, so it's approximately still equals to 0.05 molar. Okay, so that's something we also could anticipate, right? Because again, our solution majorly will be having this most basic form. That makes sense. So we also get this guy. Okay, so then the last thing will be the H2SO3. Okay, so then again, how it's related to this question? We know this H2SO3 is having this reaction, right? SO3 minus plus H plus, okay? And then in this case, this K, because that's our most acidic form, that's gonna be a quite small concentration. What that will be, we can actually do the calculation. We don't know what that is, but we know the concentration of HSO3 minus because we calculated, which is 8.62 times 10 to the negative 5. Hydrogen ion concentration, we also could calculate it because we know pH or we know OH concentration. Either way, you can calculate it. And then we know the Ka1 value or K1 value, which is 1.39 times 10 to the negative 2. Okay, so once you know all that, we can totally calculate it. K1 will equals to product over reactant H2SO3. And then you can calculate this H2SO3, and that will be HSO3 minus times H plus divided by K1, and you can put all the values in, times 2 times 1.16 times negative 10 divided by 1.39 times 10 to the negative 2 gives me H2SO3, which is 7.2 times 10 to the negative 13 molar. Okay, so that will be the concentration of H2SO3, the most acidic form, and again the concentration is very small. Okay, so we just finished calculating the concentration of H2SO3, which is 7.2 times 10 to the power negative 13 molar. Again, this we're dealing with situation B, right? Situation B is that, situation C. Okay, so when C we had Na2SO3, which is 0.05 molar. This is our most basic form, right? So that's the situation. And then now we're trying to calculate, we'll assume this H2SO3, which is the most acidic form, but now over here we have very little amount, that's what we assumed. And then we did the calculation, it fits into our assumption, okay? And then just to recall, okay, in situation A, when we had the major species was the most acidic form, and then when we were calculating the most basic form, again we assume that's very small concentration, and then turns out to be that equals to Ka2 value, okay? And then also, of course, that's a small value. So that's what we did, okay? So now, if you look at our situation, do you think, is there a relationship between the the concentration of H2SO3 with of the Kb values, right? Okay, so maybe there is. And then what this will be, we probably assume that would that be PLKB2, okay? If so, let's try to calculate it and see if Kb2 does equal to this value. Just calculate it from the traditional way. Okay, so now let's do this. So Kb2 should equals to Kw divided by Ka1. Okay, Kw is 1.0 times 10 to the negative 13, and then this Ka1 is 1.39 times 10 to the power negative 2. After you do the calculation, the value does come out as 7.2 times 10 to the power negative 13. Okay, so they do match again. So this is another very neat conclusion then. So if you have situation like this, when you have the major species is the most basic form, and then in this speaker, the little amount, the very little amount of that most acidic form, the concentration will actually equals to Kb2 value. Okay, so of course you should show me the calculation process, but then you know this value will turns out to be the Kb2 value. Okay, so this will be the end of this video, and hopefully this is helpful. Thank you for listening.